I'm not recording. Thank you, Delilah, for asking that question. Okay. Okay, coolio. I want to see how many there are here. 4, 2, 3, 4, 5, 6, 7, 8, 13, 17. Okay. Alrighty. So I'm gonna see if turning off this light over here kind of makes this screen look a little clearer, but I don't want you guys to like fall asleep on me. Is that better? Yeah. Do not fall asleep. I'll be sad. 2 in the afternoon. No time for snoozing. Alrighty, you guys had your first homework due to me today. I'll try to get those grades back to you as fast as I can, definitely over the weekend. If you have any questions about the homework, I will have solutions posted for the written homework tonight. I'm going to assign homework that's going to be like available to you guys tomorrow. So you guys can have like a break from math for a night, take a rest. And then if you want to start homework tomorrow, you can, right? Just kind of wanted to give you guys like a mental break. Thursdays are going to continue to be your homework days. So homework is going to be always due right before class at 2:50 p.m. All right. So that's not going to change all to semester. I think originally I said Wednesday evening. So I've updated the syllabus now to kind of correlate to how we're doing. All right, cool. So it's spooky dark over here. We were finishing up B3. So we had just talked about how we can rationalize the denominator. Radicals, we don't really like in the denominator. It's not simplified technically if there is a radical like this in the denominator. So, my cursor, wait. Oh, it's this one. Okay. So, the way that we can move it out is we multiply by what's called the conjugate. Basically, I just make whatever sign is right here and I switch it. So we're given a positive here. So 1 plus the square root of 2. Its conjugate, we said last time, was 1 minus the square root of 2. All right. So I'm going to write 1 over 1 plus the square root of 2. And I'm going to multiply it by a fancy 1, right? And that fancy 1 is going to look like 1 minus the square root of 2 over 1 minus the square root of 2. And then we all know how to multiply rational expressions now. 1 times 1 minus square root of 2 is just 1 minus square root of 2. On the bottom, I'm going to have 1 plus square root of 2 times 1 minus square root of 2. Let's kind of write this under it. How can I, so when I FOIL this out, I'll get 1 plus the square root of 2 minus the square root of 2, and then plus 2, right? So the benefit of that is that these middle guys cancel out. The radicals go away. So we're left with, back to black, 1 plus, oops, sorry. Let me fix this real quick. This is why I like to use notably. Doo-doo-doo. And that's going to give me 1 minus square root of 2, still on the top, over 1 plus 2, which is just 3, right? Not too bad, right? What does this multiplication kind of remind you guys of? What kind of factoring thing does that remind us of? We reviewed some factoring rules last time. Did I do everything right? Oops, I messed something up. What did I do? yeah, it's minus 2, right? Plus square root of 2, yeah, positive square root of 2 times negative square root of 2, so there's a negative. So there's a negative 1 right here. Oopsies. Does this look like a plus b, a minus b equaling a squared minus b squared? Yes.
I swear I learned that you can multiply the square root of 2 bottom and top.
So when you do that, you actually will, so you're talking about if I just kind of multiplied by something like this.
Yeah.
So when we do that, you actually are throwing the square root of 2 right here. So if I did, here, let me add 1 minuto. Oh, no, wait. Page. Did that work? Sweet. Okay. So when I do like 1 over 1 plus, let's make these blank. Okay. Plus the square root of 2, you're saying I would do something like this, right? Square root of 2. So that would give me root 2, and then I would distribute it to both terms, right? So I get square root of 2 plus 2. And I still have a radical on the bottom. And keep multiplying them back and forth will give me, like, I'll always have a square root of 2 if I do that. That's why I need to do the conjugate. If I just had like 1 over root 2, you'd be right, because that's its conjugate. The conjugate of just a number is itself. So in that case, then I would multiply it by root 2 over 2, something like that. Okay. Oh yeah, so conjugates are kind of, they use this property here, right? I had a plus b, a being 1 and b being root 2, and I multiply by a minus b, and that's how I got 1 minus root 2. So since we now know this awesome rule about difference of squares, I just know that I'm going to end up with a squared minus b squared. So 1 minus square root of 2 squared, which is 2. So that's really awesome. If you wanted to, you could simplify this guy a little further and put the negative 1 up top. So we get like negative 1 plus the root 2. But I'd be happy with both. Mostly testing you on rationalizing the denominator. Okay? How do we feel about conjugates? Good? Okay, great. We're now going to move on to chapter C, which is working. So we worked with expressions in chapter B. So now we're working with equations. So this is not right. Oh, here we go. Sorry, that was C.2. Yeah, now we're working with equations. So we say that an equation is a statement that two arithmetic, so arithmetic equations are equal. So like 4x plus 7, not 17, equals 19. E equals mc squared. Area is equals pi r squared. Oh my God, I am so sorry. Okay. Right, there's just an equal now. Expressions, we didn't have an equal sign. Now we do. So that's kind of equal equation. Expression, no equal sign. So we think of x in this situation as like the unknown. And the goal is to find the value that makes the equation true. These values are what we call solutions. So you can solve an equation and you can simplify an expression. Okay? Our main strategy for solving an equation is to isolate the variable onto one side. And we do this either by one, adding or subtracting the same quantity to each side. It's an equation, they have to equal. So what I do to one side, I have to do to the other. Similarly, if I multiply or divide on each side by something that's non-zero, why does it have to be non-zero? It would be kind of silly if I just multiplied each side 0 times 0. Then I just had 0 equals 0. That doesn't tell me anything about the solution. And I definitely can't divide by 0. So that's kind of the technicality behind why we say a non-zero quantity. Okay? So if we're asked to solve 5 times the quantity 3 plus x equal to 9x, you want to tell me what their first step would be. People online can write in the chat, turn on your audio. Might scare me, but we're fine. All right. Malik? You would distribute the 5? Yeah, me too. So we're going to have 5 times 3 plus 5x equaling 9x. And then we can simplify that a little farther. Ooh. Giving me 15 5x equaling the 9x, right? I set up here that I wanted to isolate my variable onto one side. Currently, my variable x is on both sides. It doesn't matter left or right side, which way you go. I usually like to subtract a smaller number just so I have a positive x, right? Yes, Chloe, distribute was the right answer. So I'm going to subtract 5x from both sides. Oopsies. Minus 5x. So we get 15 equaling 4x. And now that I've got an x all by itself, I'm going to divide by 4. I don't really, can I distribute? Can I reduce 15 over 4? I don't think so. And these 4 cancels out, so I'm left with 15 over 4 equals x. So I can stop here if I wanted to, but we're all really good mathematicians here. So we're going to check our answers. So over here to the side, I usually just write check. I still do this with a lot of my homework today. So I'm going to take that x value and I'm going to start at my original spot. The reason I'm not going to start here is what if I made a mistake distributing, right? I don't know. Hopefully I know what 5 times 3 is, but like, what if it's been a long night and I write 10 or something? So I'm going to start from the original and I'm going to plug in that x right there. Okay? So plug in. All right, so I'm going to have 5, 3 plus 15 over 4 equaling 9 times 15 over 4. And then PIMDAS says I need to do my parentheses first. So 3 plus 15 over 4. 3 times 4 is 12 plus 15 gives me 27 fourths. And 9 times 15 is 135 over 4. And then I can check in my calculator really fast and see that 5 times 27 over 4 is the same as 135 over 4. Okay? So great, those answers are equal. My answer is correct. So if you're ever like, oh man, I'm not sure, well, here's a great way to check yourself, right? When you guys were doing factoring, you could check yourself by expanding your 2 vectors. And if you got to where you ended to your original, everything was good. If not, probably had to reevaluate. Okay? Sorry, some of my notes are double-sided, some of them aren't. Okay, cool. So now solving a linear equation. Linear equation. A linear equation is one variable in an equation that is equivalent to one of the form ax equal to b, and I'm going to set that equal to 0. So ax plus b equals 0. So linear means I just have one variable. It isn't, okay, yeah. So A and B are real numbers. 1, 2, 2.5, 27/3. And X is our variable here, right? Kind of what we said earlier, the key technique that we're gonna do is putting all the variables onto one side. So if we're gonna solve 7x minus 4 equaling to 3x plus 8, what are we gonna do first? I'm gonna rewrite the equation. They're all in the same line. We can add the 4, absolutely. Remember, there's no correct first step, second step, or correct order to most of these. Whew. Oh no, hold on. Winston. Hold on, Notably's being weird. Okay, we're fine now. Cool, right? So I can add 4 to both sides. So I get 7x alone equal to 3x plus 12. But both my x's, I still have x on both sides. So I need to subtract that 3x over. Why am I subtracting 3x instead of subtracting 7x? Right, I already put the constant on the one side. It would kind of be redundant to move everything to the one side. So I kind of, when I'm saying I want all the variables to one side and I want everything else to the other side. So I get 4x equaling to 12. And then we can divide. And x is equal to 3. For time's sake, we're not going to check our answers. I already did them, so I know that they're right. But I'll show you cases later while it's really good to check your answers, okay? So what if we have something with a bunch of fractions? Pretty gross. Now, if you like fractions and you want to keep them, that's totally up to you. Me, I don't like fractions. So what we're going to do is get rid of them. What can I multiply by each side to get rid of all these fractions? The reciprocal is a good idea, but I want to do a least common denominator would be probably the best thing, right? So thank you, Delilah. 3, we could put the x up here if we wanted to. So I have 6 in the denominator, 3 and 4. What is the least common denominator of those guys? 12, right? If you didn't know and you just put in 6, you could have eventually gotten to 12. This is also simply a preference. Yes, Carolina. Yes, I believe so. Right, because 3 times 4, they have no, they're both, okay, 4 is not prime. 4 is just 2 times 2, and 3 is prime. And then 6 is 3 times 2. So then, yeah, we need another 2 in there. Yes. You could do that as well, and then like multiply across by a 12. That's essentially what we're doing. So this is just a preference. So what you're saying is that I can rewrite this as 2x over 12 plus, what is that, 3 times 4, 2 times 4, 8 over 12 plus 9 over 12 x, right? Get a common denominator, and then, yeah, essentially multiply by 12. It's all the same thing, right? That's why I'm kind of stressing that, like, whatever you're most comfortable with is, and that is still mathematically correct, is going to be the best for you, right? There's more than one way to do one problem. So when I multiply out this 12, I'm going to get 2x plus 8 equaling to 9x. That looks like a lot easier to deal with than all these fractions, in my opinion. If you love fractions, I am sorry I'm hating on fractions so much. So I'm going to subtract 2x on each side. So I have 8 equal to 7x, divide by 7, and we get x equals 8 over 7. Not too bad, right? Yeah, if you wanted to keep everything in fractions, you still would have gotten to the same place. All right, is everyone okay if I move on? You're still writing. Okay, cool. Yeah. So I know we didn't check on our last ones, but you guys should always check your solutions. Even if you don't make mistakes and you do all of your math right, there are solutions that are called, I have to write this word and then I need to pronounce it. They're called extraneous, yeah, extraneous solutions, where I do all the math and I do it right, but when I go plug it back in, it's something, I'm either dividing by 0, I'm multiplying by 0, something's happening and it's not okay. All right. So kind of like what I said earlier, that last problem, I don't want these fractions. So for 2 plus 5 over x minus 4 equaling to x plus 1 over x minus 4, I'm going to multiply each side by the denominator, x minus 4. Okay? Well, that's going to leave me with 2 x minus 4 plus 5 equaling x plus 1. I'm going to distribute this 2x minus 8 plus 5 equals x plus 1. I'm going to subtract x on both sides. So I get x equal, no, x, what's negative 8 plus 5? Negative 3 equaling 1. So x equals 4. But if I go back to my original problem, which was 2 plus 5 over x minus 4, x plus 1, x minus 4, and I plug in, I get 2 plus 5 divided by 0 equals 5 divided by 0. I can't divide by 0. Remember how we said we could multiply each side by something that is non-zero? When I got the solution x equals 4, it invalidated this multiplication by x minus 4 because I was essentially multiplying each side by 0, which I can't do. Well, the only solution I got, if I plug it in, I get something that doesn't work. So we say that there is no real solution. And we actually have this come up quite a lot. Alrighty? So that's why we always want to check our answers, right? We did all the math right, but we just got something to be a little weird. Okay, cool. So now we're gonna move on to, is everyone okay with this? Cool, yeah. So power equations. Power equations is gonna be x to some number equaling another number, right? It's not a number raised to the x. That's something different, and we'll talk about that later on. So if I have x raised to the n equal to a, it has the following solutions. X will equal the nth root of a if n is odd. And it'll equal plus or minus the nth root if n is even and a is greater than 0 or equal to 0. Remember, if we always take the square root of something, it's always plus or minus that root. This is the same property. I just extend it to all even integers. What if n is even and a is less than 0? It's going to look like nth root of like -1. So we say that the equation has no real solutions. What? Okay. Does that make sense? Right? I can take the cube root of a negative, but taking the square root of a negative, not cool. All right. So now we have a few examples, which I think are pretty cheeky. X to the 5th equaling 32. Who can help me out with this one? Carolina? Of 32? Mm-hmm. So if you want to think about like taking the 5th root of each side, we know from exponent rules that those are going to multiply. So I'm going to be left with x to the 1, which is just x, and 32 to the 1/5, which we can just write as the 5th root of 32. Does anyone know what the 5th root of 32 is? It's 2, right? Is it just positive 2? Ooh. Think about it again. It's just positive, right? Because I'm taking the 5th root, so n in this case is odd. So I'm only going to have positive 2. The way to do that is we can also check, right? 2 to the 5th, I know is, I can plug that into my calculator really fast and I'll get 32. But if I plug in -2 to the 5th, I'll get -32 because there's an odd number of those negatives. So only like 4 of them will cancel out. I'm left with 1 of them. Okie dokie. So now I have x to the 4th equaling to 16. Just like before, I'm going to raise everything to the 1/4. So I'm going to get x equaling to the 4th root of 16, which what can I simplify that to? Plus or minus 2. Oh, not square root. Just 2, right? And to the side, I can check that again. So 2 to the 4th, it's going to be 2 times 2 times 2 times 2, which is also just 4 squared, blah, blah, blah. I get 16. If I do -2 to the 4th, well, all those negatives are going to cancel out. So again, I'm going to get 16. Okay? So sometimes I'm going to have 2 solutions. Sometimes I'm going to have 1 solution. And sometimes we're going to have no solutions. All right? So x to the 5th is now equal to -32. So we can kind of use what we did before. Looking up at the first example, and we can take the 5th root of -32. But I have a negative in my radical. Is that okay? It is okay. Why? Because 5 is odd. So what I can do, this might make you guys feel a little bit better about having a negative in the radical. 5. I can write this as -1 times 32. And then I can write this as the 5th root of -1 times the 5th root of 32, which is just -1 times 2. We've got 2 look a little better. And that's how I get -2. All right. So that's why the negative can come out, because an odd root of -1 is -1. Okay. Does that make a little bit more sense why the 5th root or in any odd root will give you a negative back out? Yes, Mathis?
The negative one that you do that in any problem, right?
With a negative involved, right? If something is like a negative, if a number is a negative value, you can think of it as times a -1, the positive version of it times a -1. We also did this when we were talking about absolute values. If you guys remember that a while ago. Yeah, Carolina. So, yes, the 5th root of 32, yeah, and that we use that from up here. Right, remember you guys are allowed to use your calculators on homework and in class. I'm not going to give you like crazy numbers on exams or the final. Like the most, I think we talked about this last class. If I can't do it in my head in like under like 10 seconds, I'm not going to give it to you guys, okay? What else? But does it make sense that the 5th root of -1 is -1? Okay, cool. So what about x to the 4th equaling -16? Do you think I'll have 2 solutions, 1 solution, or no solutions? No solutions, right? I would get x to the negative, x equal to the 4th root of -16. 4 is even. I can't have that. So I say no real solution. And I should enunciate when I say no solution, because we're kind of only dealing with real numbers. There is a solution. It's just an imaginary number. You guys don't need to know about that. I don't know when they ever, I think Calc 2. So in a few semesters. So don't worry about it right now. So there, we say there's no real solution. So I'm going to enunciate that a little bit more. All right. Any questions about this so far? Okay, cool. Now we're going to throw in a little bit more curveballs and do a few more examples. All right. Making great time. Cool, yeah. And then, okay, we might not do all of this depending on how you guys are feeling. But we'll see, okay? So if I have x squared minus 5 equaling to 0, I kind of need to use the stuff that we talked about in the last few sections, right? Math builds on itself. So we're going to kind of build from what we learned earlier today. So x squared minus 5 equaling to 0. Who wants to tell me their first like intuition of what we should do? Yes. I would add 5 to both sides. Just because x squared, I still want to get my variables all to one side by themselves. So I get x squared equaling to 5. And then I'm going to take this. I can also write it like this, square root. So I get x equaling to, yep, plus or minus the square root of 5. All righty. I will be very sad if you just tell me this is just the square root of 5. You're only giving me one out of the 2 answers. Okay. Well, now I have x minus 4. If you're saying this out loud, you say x minus 4, the quantity squared. That's just kind of how you verbally talk about this equation, equaling 5. All right. So Someone that hasn't answered a question for me today, want to tell me what they would do first. People online can also throw some suggestions in the chat or turn their mic on if they want to. Yes, in the back. Right, we would square root, right? So I would get, let me rewrite this really first. 4. So I want to take square root. So I'm going to get x minus 4 equal to what? Can you tell me? Say it again. Not just the square root of 5. Yeah, plus or minus square root of 5. So even though I'm not done with the whole thing, I still need to remember if I'm taking the square root or any even root, I need to tack on a plus or minus. Why am I not adding it onto this side? It would kind of be a little redundant if I just had a plus or minus between everything. So we only kind of put it onto one side, and usually when there's just a constant, okay? Get rid of these. So then I'm going to add 4 until I get that x is equal to plus or minus the square root of 5 plus 4. I can also write that as 4 plus or minus the square root of 5. Both of those are the equivalent. I just switch the order, which I can do because I'm adding 4, subtracting 4 gets a little messy, okay? How are you feeling with that so far? Feeling pretty good? Thumbs up, thumbs medium, thumbs down? Oh gosh, great, okay. I just kind of pulled these randomly out of the book. Let's skip 3. I think we have a pretty good, we've done those a few times, but I'm still gonna write these out when I get home. So try this one on your own later if you're still having a little trouble, and I'm gonna post the solutions to everything on the notes after class, the same, all right? So let's look at 4. Oh, that's a good question. So if I foiled x minus 4 squared, we're actually going to talk about solving quadratic formulas like this in the next section. But that's a really good question, Chloe. You would get too many x's, and then it would be a little bit harder to we're not there yet. That's what I'm going to say. We're going to learn more ways to do that later today in like 15 minutes. So that's a really good question. Okay, cool. So moving on to 4. So if I have 16 to the 4th equaling to 81, should I do first? Should I take the 4th root first, or should I divide by 16? I'm going to divide by 16, but honestly, it doesn't matter. So I can divide by 16. So I'll get x to the 4th equaling 81 over 16. I'll take the 4th root of that. And I think we've all been told this before, that we don't really like fractions inside radicals either. So I can split them up. We learned this one of our exponent rules. I can write the 4th root of 81 over the 4th root of 16. But what did I forget on this step down here? I heard it. Yeah, I forgot my plus or minus, which is, it's when you're taking the square root of something, you guys are more familiar with doing that. But on other even roots, as I just showed, it's sometimes easy to forget. So that's why practicing this helps. When I split this up into 2 4th roots, I'm only going to do 1 plus or minus on the top, just because, again, it would be really redundant for me to do plus or minus over plus or minus. they would just kind of cancel out and it'd just kind of be silly. So I'm just going to attach it to my numerator. Plus or minus the fourth root of 81. Well, I know that 81 is 9 squared. Let me do this to the side. That equals 9 squared. Well, 9 is 3 squared. So this is like 3 squared squared. So I get 3 to the fourth. Oopsies. So the fourth root of 81 will be plus or minus 3. And then similar for 16, I know that's 4 squared, which is just 2 squared. 2 to the fourth. This is how I think about it. I don't know if this helps for you, but I like to show like what's going on in my little mind. And then, so the fourth root of 16 is 2. Remember, I'm not putting plus or minus 2 here, just because I'm kind of taking account for it in the numerator, right? And then we're just kind of done from there, right? We have positive 3/2 and negative 3/2, and those are our two answers. Yes, Mathis. It would be half wrong, right? Because that's only one answer out of 2. So I'll be a little lenient on our first exam, but definitely by the second and third, if you do just give me the positive version, I'm going to be pretty sad. Okay? It's on the syllabus. I actually updated the syllabus with our WebAssign information, and also I think originally I said homework was due Wednesday evening instead of Thursday before class, so I also updated that, and I updated that homework would be posted on Fridays instead. But the calendar is still the same right now. I think we're just like half a day behind right now because we were supposed to do this section Tuesday. But the sections that each exam covers is the same. So once we finish the last section of exam 1, I can't remember what it is right now, then a week later, you'll have your exam. And it won't be in class because I just don't know how to do that in this situation. So yeah, it's a good question. All right, cool. So now I have decimals. Gross. But thankfully, it's only to the 10th place. So I think I can actually make these decimals into fractions. I know I talk about fractions a lot, but this will actually help us a little bit. So does anyone know what 0.6 is in fractions? Can I have a hand raised in the back, please? 1/6. Did you say 3/5? I'm gonna act like you said 3/5. All right. God, it is Thursday afternoon. Like, this is the last thing I have of the week. My brain's tired too. Okay, cool. So 3/5, and then 0.2 is also. Excuse me. Rude. Okay, cool. So if you didn't, you could have just done 6/10 and then reduced down to 3/5. That's how we do it. Carolina? Okay. Here, I'll write this to the side. 6/10, and then we can reduce that to 3/5. Okay. So up here, we could have done the fourth root first. 1 second, Mathis. And then divided by 16, but here it seems like I should probably get rid of this guy first because I don't know what the fifth root of that is. And 3 and 5 are both prime, so I'm pretty sure they don't reduce to any nice fifth root. Mathis, what was your question?
Is it 6/10 because place?
Mm-hmm.
Like if it was one more place, the denominator is different, right? Like if the
Yeah, that's how you do, what are they called? Decimals.
and then you just simplified it.
Mhm. Exactly, yeah. Right here, I would do like 3/50. Something like that. I'm not sure if we ever go into anything like that. Probably not. Okay, cool. So I'm going to get rid of this 3/5 first. And I think we talked about this earlier and someone mentioned it. I'm going to multiply by the reciprocal now. I didn't earlier just because I had a lot of fractions going on and it was just easier to multiply by the least common denominator. but now we're going to multiply by 5/3, right? Because that's the reciprocal of 3/5. So I get 5 times 3 over 3 equaling x to the 1/5. Well, those 3's cancel out. So I get 5 equal to x to the 1/5. Well, so far, I've only kind of seen exponents that were whole number integers. Now I have 1/5. So what I've been doing is multiplying by, I would do over 1/5, right? Something that looks kind of like 1/1/5. What does that equal to? 1 divided by 1/5. It actually just equals 5. And I can show you that over here. 1/1/5. Remember, we divide fractions is keep, switch, flip. So this is like saying 1 divided by 1/5, which is the same as 1 times 5. I'll let you guys think about it for a second. Okay, so I have 5 to the 5th and an x. Beautiful. 5 to the 5th. Oh, I have it written down. No, I don't. Just kidding. I know it's gonna be like 125 because that's 5/3 times 25. But this is, if you gave me 5 to the 5th on like an exam, happy camper. I don't expect you to know 5 to the 5th. 5 cubed, maybe. Okay, but we're gonna just stop and say x is equal to 5 to the 5th. Right? Is everyone feeling okay about this? Let's do like thumbs up, thumbs sideways, thumbs down. Okay, cool. When you start doing your homework this week, and you're like, oh man, now I'm actually doing these on my own. I'm actually super lost. Remember, there's always your optional homework that are going to be similar to homework problems, but again, they're not, the optional ones aren't graded. So if it says optional homework, that one's not graded. If it's just homework 2, that one's graded. Okay, cool. So now we have a negative exponent. So we have lots of different options now that we can do. And it's up to you guys. So who wants to tell me what they would kind of do first? Oh God. Ugh. Give you a second to think about it. I don't want to pressure you. Let's go over here. Right, I would divide by 3 first. So I get x to the -5th equaling 2/3. Then what should we do? Or what can we do? Ooh, I heard a mumble. Can I have a louder mumble? Whoever said it. So can you say it one more time? I'm so sorry. Right, -1/5, like that. Is that what you're saying? Right. So it'd also be like, right, -1/5 is the same as 1/-5. So that'll give me with x equaling 2/3 to the -1/5. How can I simplify this a little further? Remember, we don't usually like negative exponents. So what can I do? Want to tell me what are their exponent rules? Would you guys agree that I could write 2/3 to the -1 and then to the 1/5? Right? You guys are just staring, so I wasn't sure. So, right, I can pull that negative inside, right? Kind of like reversing this rule. And then if I have something to the -1, what do? I just flip it. So I'm going to have 3/2 to the 1/5. And if you put this in your calculator, you can get like 1.08. I'm okay with this fraction being in to the 1/5 just because I can't really reduce it anymore. Down the line, we'll get into more detail about stuff like that, but right for now, I'm perfectly happy with this number, right? Is that a question? Yes.
When it gets to the like 2/3 to the power of -1/5,
Yes.
so we just flip the fraction and then start out that step.
If you went from here to here, I would understand what you're saying. Yeah, I was just kind of showing the intermediate step. All right, that's a good question. Carolina? So when I have something to I'm gonna yell at these men. So when I have something to the -1 power, I'm basically saying that, right, if I have x to the -1, I can rewrite that as 1 over x. Right, it's currently over some 1, an invisible 1 really, and it's not happy. It's in the numerator and it's not happy right now. So it's going to be happier if I put it down in the denominator. For 2/3, you can think of it's a little bit more difficult. So we say like 2/3 to the -1. That would be, if we want to think of 2 to the negative, 3 to the negative, well, neither of them are happy where they are right now. So 2 is going to go to the bottom and it's going to be happy there. So it's going to have a +1 exponent. And then 3 is going to be happier up there. So that's why. Also, if you guys don't like when I say that an exponent or a number is happy, that's how I was taught it in algebra. And I've never forgotten it. And I also like to think of numbers as happy. So I think that's pretty cute. Okay, cool. How are you feeling so far about power functions? We're getting into more in later sections. So if you're still feeling like, we'll get more comfortable with them. Is that a question?
About like, are we always going to have for the not the written online? Is it always going to be like 20 attempts on these?
It should be. I think I accidentally made it 20. It's supposed to be like 100 because you're supposed to, have the belief that homework you're allowed to make mistakes on and you're supposed to be learning and getting more comfortable. So I'm going to change it to 100. It won't let me just be unlimited. It has to give me a limit. But yeah, and then, yeah, so you'll always have WebAssign homework and it should be up to 100. I'll switch it. Okay, cool. Good question. Moving on. So what if we like have more than one variable, right? So that's kind of what we see in more everyday terms. If I'm calculating profit, I have, oh God, it's been so long. I have revenue. I have my costs. I have all these different variables moving around. And sometimes revenue might depend on the time of year, what's happening elsewhere. So even more variables going on, right? So that was like kind of like a business situation. In science, you have so many equations based on so many different other variables. That's kind of the math that I do. So we'll also often want to find one variable in terms of the other. And we just treat the other variables like numbers, right? So when I say solve tx equal to 2t plus 3x, t, I'm going to act like it's like 4 square root of 2 something, right? It's still a variable. I could plug it in if you give me t equals something. But for right now, when I say in terms of x, I want my end product to be x equals, okay? Which might be like kind of, I understand if you write t equals because you're like, oh, t is in terms of x, but I want this whole equation as x equals, okay? So if I have tx equal to 2t plus 3x. Remember, I want to get all of my variables on one side. So if I'm getting in terms of x, what's my variable? X, right? T, I'm treating as a number right now. So what can I do first? Where? Let me rewrite this T, hold on. A loop-de-looped T. Oh my God, no, go away. So what I would want to do is I'm actually going to subtract 3x from both sides. I have an x over here, and I have just a 2t by itself. So 2t in my eyes right now is a constant, right? So I get tx minus 3x equaling to 2t. Coolio. I want to get x alone now. Let me rewrite this because it's kind of ugly. How can I get x alone? What should I do? So if I divide by t, I have to divide everything by t. So let me rewrite that. So I get x minus 3x divided by t equaling 2. That kind of looks a little bit more messy. There's nothing wrong with doing that step. You can still get to the end product, but we're going to backtrack a little bit. So just to make our lives a little easier. Ashley, did you have your hand raised? Yes. Yeah. So yeah, you're absolutely right, right? So I'm going to factor out an x, right? And I'll get t minus 3 left over. And 2t I didn't really touch at all. So that's why we reviewed factoring before reviewing solving equations. When I say LHS, that stands for left-hand side, by the way. Yes, Mathis?
Like before you erased everything, was that correct?
It's not incorrect. It's not very streamlined. So I have this. What I would do from here, we can work on this after we do this one. I probably shouldn't have shut that out so fast, and I apologize. This isn't wrong, but it just makes our life a little harder. Because you would like add it over. I think you would eventually just kind of walk in circles, really, with that problem. But we'll go into that a little further. Okay, cool. So then I would get x, I would divide by t minus 3, because I want x equals. That's my end goal. So t minus 3, t minus 3. And I'm going to be left with x equals 2t over t minus 3. Then we're done. If we divide each term by t, I can't really get, I can pull an x out from each term, and I'll get like 1 minus 3 over t equaling 2, and then I could divide over. But if I tried to like add 3x over, I wouldn't be able to like then divide by x again. It would have been a lot of finagling. Also, having a fraction in the denominator isn't pretty. I think both of those are equivalent. Ooh. The trouble about this though, is What if t equals 0? I don't know any limitation of t. It's usually time, but I usually like to start at time 0. So that's why sometimes dividing by a variable like that might be a little sketchy. Right here, t equals 3 would be a problem area. But yeah, just kind of giving you a reason maybe why that wouldn't be super fun. Okay, cool. Newton's law of gravity. We experience it every day. Oh, my computer's on 20%. We're given F equals big G times little m times big M equals, divided by R squared. So I can either tell you to solve it in terms of X or just solve for M. Those mean the same thing, right? So take a few minutes, because I need to plug in my computer again, and see if you guys can solve for big M. Big M and little m, two different dudes. All right, who wants to walk me through what they did for their first step for solving for big M? Yes. Oops, let me, so we have big F equal to, so we're gonna multiply each side by R squared. So we get big F, R squared equal to big G, little m, big M. What can we do next? Yeah, or yeah. Ooh. Yes. So you subtracted G. Why would you subtract G? It is connected, we mean multiplied. So yeah, when we put the G right out front, it's like G times that big chunk. So instead of subtracting, what should we do? We can divide, and we can do two steps at once, and we can actually divide by G and little m, right? So that I'll get big F times R squared over G times little m equals big M, right? Not too bad. Okay, how are we feeling with solving kind of the basics of solving equations so far? Okay, great, coolio. So now we're on to C.2, and we are going to talk about solving quadratic equations, right? Where's my notes? Solving these types of equations, there's not just one way to do it. So first, let's just talk about what a quadratic equation is. So we say a quadratic equation is an equation in the form a times x squared plus bx plus c equals 0, where a, b, and c are all real numbers, and a should not equal 0. If it equals 0, what is that? It'd just be a linear equation, right? If I no, not duplicate, delete. See if I can do this. If I just deleted that, that looks like linear equations, what we just kind of talked about. So that's why I need a to not be 0. Okay? So what we're going to do in this section is we're going to dive deeper into 3 different methods for solving quadratic equations. One of them, the first one we're pretty familiar with. We're going to do it by factoring. The next one is by what we call completing the square. Does anyone know what the last one is? Yeah, it's called the quadratic formula. In my experience in math, I've heard a lot of different ways to remember it, and I will sing to you my way once we get there. Special treat. Okay, cool. What time is it? Perfect. Okay, cool. So we're going to talk about factoring first because that's what we've had most experience with. Then we'll talk about completing the square when factoring isn't too easy. And then quadratic formula is, I can't do any of those. What do I do left? Right? So factoring comes in useful when we use something called the zero product property. If I have 2 arithmetic operations or expressions multiplied by each other, so a times b, and those equal 0, at least one of them has to equal 0. Right? So that's why we say a times b equals 0 if and only if. It's a very strong implication in mathematics. It means really I can start here or start here and I'll get the other result. So if a or b equals 0, a times b is 0. If a times b equals 0, one of them also has to equal 0. Okay? So this property is what we use to solve quadratic equations that can be factored. If it can't be factored, we'll talk about that later. All right? So first we're going to set the quadratic equation equal to 0. I'm not saying just cross out whatever's on that one side and set it equal to 0. I mean, you might have to move some variables and constants around all to one side of the equation, so that would just get equal to 0 on the other side, right? Then we're going to factor and set each factor equal to 0 and solve, all right? So kind of what I just said, it only really works when one side equals 0. So if I have like x squared plus 2x equaling to 84, I can't just all of a sudden write x squared plus 2x equals 0, right? That's not what I mean with setting it equal to 0. I mean subtracting 84 on each side. So no, yes. Okay. So these next 3 problems are pretty cute. I think that's all we're going to try for today. Okay, cool. So how can I factor x squared minus x minus 12? I know that I'll need, I already have it equal to 0, so I kind of don't need to move anything around. So I'm looking for 2 numbers that multiply to negative 12 and add to what? -1, right? There's like a hidden 1 right here. So I kind of like writing out, ooh, thank you, Ryan. If you go through the different factors of -12, you'll eventually arrive at -4 and 3. So I'll write x minus 4, x plus 3 equal to 0. Scroll up. So what have I done so far? Set the quadratic equation equal to 0. It was already done. Check. Factor the quadratic equation. Just did that. Check. And set each factor equal to 0 and solve. When I mean solve for the variable, right? So I'm going to set x minus 4 equal to 0 and x plus 3 equal to 0. Simply adding or subtracting the constant to either side, I'll get that x equals 4 and x equals -3. We factored it. So, right, yeah, x minus 4, x plus 3. When I FOIL, so my first, I'll get x squared minus 4x plus 3x minus 12, and then simplify from there, right? Good question. Because we're going to deal with one that has squares later. All right, cool. And we're done right there, right? My answer is 4 and -3. The common thing here is to be like, oh, -4 and 3 are my solutions to my factors, so those should be the solution for x, right? Opposite. X equals 4 and x equals -3, okay? So for number 2, I'm lucky enough that it's actually already factored right now, and it just happens to be the 2 factors from before, but it's equal to 8. So what should I do? Should I set 1 equal to 8? Right, I have to FOIL it back out. I have to expand. I can't say that like x plus 3 equals 8 or x minus 4 equals 8. Oopsies. Doesn't work like that. So we're going to FOIL. Well, I kind of just factored up here, so I know what it should FOIL out to. X squared minus x minus 12 equaling to 8. So my first step was to get the quadratic equation equal to 0. So I'm going to subtract 8 on both sides. And I'll get x squared minus x minus 20 equal to 0. Now I can factor. I've got my equation equal to 0 now. Now I can factor. So how can I factor x squared minus x minus 20? I know one of them is going to be negative. One's going to be positive because it's -20. Yeah, -5 and 4. I always I like draw little like sets of them. So I do like -20 and 1. No. -10 and 2. No. -5 and 4. And then ta-da, you get it. All right. So now I'm going to set each factor equal to 0 and solve. So we get x equals 5 and x equals -4. Have you noticed a trend with how many solutions I get from each problem? I get 2, right? If I have a polynomial, the largest root, it's called the fundamental theorem of algebra. I'm going to have that many number of solutions when I set that polynomial equal to 0. Fun fact. Okay. So now I have x to the fourth. So I can have up to how many solutions? Do you guys think? If I had x squared, I'd always get 2 solutions. Now I have x to the fourth. 4, right? But remember, sometimes we don't always have real solutions. So we talked about a few sections ago, making our lives a little easier. Ooh. I'm going to leave you with this, and I want you guys to try to set y equal to x squared, so that we get y squared minus y minus 12 equal to 0, and factor and solve from there. Remember, the question gave me x's, so I need to give it x equals back, not y equals back, okay? And I think we are out of time for today, right? 4 or 5? Gosh, you guys were so into it. Okay. Woo. So exit slip. Our room number is still my last name in all caps, 943. Our teacher question of the day is going to be what is x to the fourth equal to 81? Wait, not what is. What is x? Hold on. I can't write problems really fast. Remember we doing these on Socrative? Have a nice weekend, guys. If you guys have any questions about stuff, I'll be up here for a little bit. Thank you, Julia. I hope that I get to see you guys on Tuesday. I hope. Maybe not. My bet is on next Wednesday.
Next Wednesday.
So we haven't learned about exponential growth, but we'll talk about it later. Yes. Okay. For future things, oh my god, I love your colors. I really want these submitted online. I'll take this today and upload it. But on Blackboard, there's like a little submission thing. I'll take it today just because it wasn't too clear. Okay. All right. But just for future references. Okay. If you want to take a picture of it now and upload it, oh, actually, it might be a late assignment, so I can take it. Okay. But yeah.
So like write it out, take a picture, and then upload it.
Mm-hmm. So there's an app called Adobe Scan. It's free. I use it. I've gotten my like 7-year-old professors to use it, so like I promise you guys can understand how to use it. Okay. And it takes a really great picture of it, so that you guys can, and it makes it a PDF, so it's super easy to like put it up there. All right. Just in case you guys don't have like a scanner. Okay.
Yeah, were we supposed to like take a picture, scan it, and upload it? Because I didn't do that for the handwritten name.
Do you have it on you?
Yeah.
If you want to give it to me, I can take it this time.
Okay.
But for future references, just because I'm not saying you guys have germs, but like you might. I'm gonna spray these down with Lysol. I'm kidding.
I didn't realize.
Okay, no, it's fine. Yeah.
Okay.
I was hoping because like.
Yeah, I'll take pictures and put it on like a Word document.
Oh yeah. Adobe Scan, guys. I'm gonna email it about it. Does it all have your names in it? Okay, great. Thank you. Thank you, Jack Kelly. Yeah. Hi, friend.
Hi.
Thank you. And Connie, great to have you on it.
You know, like one yesterday for like the one on Webathon.
Mm-hmm.
I didn't know how to really bring part of
This one?
Yes.
Did you email me on it?
No, man.
Okay, someone else did. Okay, cool.
Okay.
So this one, can we divide it by anything? Ooh, how can we? I think this is going to use a fun formula that we've learned.
Okay.
Yeah. So 16. What I'm seeing, the reason I'm seeing that is because 16 is 4 squared and 9 is 3 squared. So I can write this as 4u, that quantity squared. Let me get this out of the way. Thank you guys.
So,
4u and then the quantity squared. So when I say quantity, we want to do parentheses. Beautiful. And then minus 24u. So what is, if we have a squared minus something plus b squared, what do you think that middle should be? If we're going to use, I don't have it. I think this was before my time of having. Okay, wait, let me stop recording and pull up my notes. Top share. Doo-doo-doo.